In Form 1, we learnt about some instruments such as meter rules, rulers, density bottles, etc. that can be used to take measurements of lengths, volumes, densities, etc. In this topic, we are going to introduce other instruments that can be used to measure very small lengths or other lengths such as diameters of beakers, test tubes, boiling tubes, etc. The new instruments that we will introduce in this topic are Vernier calipers or callipers and micrometer screw gauge. These are instruments that enables us to measure tiny lengths. Commonly used calipers include engineer's calipers, and the vernier calipers that we are going to discuss in this topic. Vernier calipers. As stated earlier, vernier calipers is a device that is used to measure smaller lengths. It can be used to measure depths, it can be used to measure diameters of solids, and also the diameters of hollow containers. Such as boiling tubes. Vernier calipers has a number of features that enables it to measure such lengths. We have the depth probe, which is used to measure relatively smaller depths. We have the outside jaws, which measures external diameters. And then we have the inside jaws that is used for measuring internal diameters. In order to measure these lengths, we have two scales in our vernier calipers. We have the main scale which is the scale on this plate. And we also have the vernier scale, which is capable of moving. So we have the main scale and the vernier scale. These are the basic features that enables the vernier calipers to carry out its function effectively. Using a vernier calipers. Now, a vernier calipers has two types of scales. It has the vernier scale and the main scale. The vernier scale has 10 equal divisions. The length of the vernier scale, however, is 0.9 centimeters. This implies that each division in a vernier calipers has a length of 0.9 divided by 10, which is 0.09 centimeters. While that of the main scale, the length of each division in the main scale is 0.1 centimeters. The difference between the length of each division on the main scale and that on the vernier scale is what we call least count. So least count is therefore given as 0.1 minus 0.09 centimeters. So in a vernier calipers, the value of the least count is 0.01 centimeters. In definition, we define the least count as the difference between the length of each division on the main scale and each division in the vernier scale. As stated earlier, we take readings from the two scales in order to be able to use a vernier calipers to take a measurement. So a measurement is taken from the readings of the main scale and the readings of the vernier scale the two are taken and summed up in order to get the length. So we therefore say that any reading is given as main scale reading plus vernier scale reading. In order to take the vernier scale reading, we count the number of divisions to a point where the calibration coincides with a division on the main scale. The total number of divisions is then multiplied by the least count in order to get the vernier scale reading. Example: write down the readings shown in the scale below. So in this case, we have to take the main scale reading. The main scale reading starts from 0 to a point where the 0 of the vernier scale starts. So we count 1, 2, 3, 4, 5, 6, 7. However, there are 10 divisions between 0 and 1, and therefore each division has a value of 0.1 centimeters. So if we have 7 of them, then that gives us 0.1 multiplied by 7, which is 0.7 centimeters. Vernier scale reading is counted up to a point where we have the coincidence. In this case, the coincidence between the calibrations of both scales is at this point. So we count the number of divisions up to that point. These are 1, 2, 3 divisions. So we take the 3 divisions and multiply by the least count. Which is equals to 0.03 in this case. The reading of the scale, therefore, is equals to main scale reading plus vernier scale reading, which is 0.7 plus 0.03, and this gives a value of 0.73 centimeters. So the reading represented by this scale is 0.73 centimeters.